Hello and welcome to episode 14 of How to Code Games in BBC Basic. In this video we're going to be taking a look at resident integer variables. The last video in the series we were looking at this proc display invaders, and I said at the time that there were some references here to some variables such as this I percentage, O percentage, J percentage, in fact quite a few letters of the alphabet here that I effectively skipped over because I wanted to spend a little bit more time understanding what these are all about, and that's what this video is actually going to be about. So I said before that variables are really just a way of storing particular values. It's a way of getting the computer to remember a particular value, and then you can obviously access that value later on, or indeed set the value to something else. And in general, a sort of good rule of programming, whether in BBC Basic or any language, is to make sure that your variables have meaningful names. And we've seen plenty of those already, things like space percentage, which defines our dim array for the grid. Although we haven't looked at the procedures that manage them, we've also got variables like missile percentage, which, as you might expect, it relates to the position of the missile on the screen, mystery percentage that dictates whether or not there's a mystery flying saucer flying, and so on. And there are plenty of other good examples. You can see one down here, left percentage, for example, to indicate whether the space invaders are moving left or right. But then why have we got so many of these variables here that just have a single uppercase letter? And that seems to go against the spirit of having meaningful variable names. And that's correct. It does go against the spirit, but there's a reason for it. These are what are known as the resident integer variables in the BBC Micro. And they are, well, there's 26 of them, starting from A all the way through to Z, and they are preloaded into memory. And therefore, they represent a really good way of speeding up the program's overall performance because you don't have to define them up front. So BBC Basic already knows that they're there. It's got pre-allocated memory, hasn't got to go and find a bit of memory to stick the variable in, and therefore accessing and returning the values of these variables is much faster. Now, this isn't to be confused with zero-page memory. For those of you that may have come across that before, that's a slightly different concept. That's relevant for if you're programming in assembly language. These resident integer variables don't exist in zero-page. They have their own memory address, which we'll have a look at in a minute. But basically, these are resident integer variables, and they're really good for speeding up the program. But of course, they do represent their own challenges. Not only are they not very meaningful because they're just letters, but also they can be accessed and used by a lot of different procedures throughout the program. And this can be further complicated if you have procedures like this one here, which actually include one of the resident integer variables as an input variable to the procedure itself. So there's a few concepts I want to spend a bit of time unpacking. First of all, just to demonstrate that what I've been saying is indeed accurate, if we open up our basic prompt here inside my BBC Micro emulator, and I just do a simple print a percentage, you can see that I've been playing around in here earlier, and there's actually a value in there. But for example, if I was to do B, C, D, well, actually I could have left it as F, all the way through to Z, you can see that these values already exist. Now, that's not a trick. Obviously, if I tried to do something like AGH or something like that, you can see that there's no such variable. Does not exist as a variable. But any of these single letter ones, A through Z, they do exist. If you were to change the case, by the way, so if I try to do A percentage, that will indicate that there's no such variable. So you do have to stick with the uppercase. Yes, that's how they are. Now they all come preloaded to 0 when you first turn on the BBC Micro. The reason why a percentage there has got a value of 23 is because I was doing a little bit of playing around, preparing a little bit of sample code that I'll be using later in the video. But they all start at 0, and they can actually be referenced not just within the same program, but across programs as well. So if I was to run one program, come out of that program, and then run another program, a completely different one, the values that have been set in those resident integer variables will persist across programs. So there are a number of examples of that in I think it's the welcome cassette that came with the BBC Micro. I think it uses the M percentage, which I think I've currently got set to 0 still, to indicate whether or not there was a cassette that had been read previously. So it's quite helpful when you want to load multiple programs in sequence to make use of some of these variables to persist values across. They actually even persist if you were to press the break key, which I'm not going to do in this video because I've got a little bit of basic preloaded, which I'd like to make use of in a little while. But if I were to press the break key or reset my emulator, the values that I'd set, so for example, the fact that a percentage is currently set to 23, that would actually persist even after the break key had been pressed. So that's quite a useful feature. It also means that you can exit out of a program and have a little peek at the variables themselves. So I said before that they are basically at predefined memory addresses. Those memory addresses start at 0404, which is the a percentage address. So I've been doing simple print commands here to see the values, but I could equally use the peep or peek command, which is used with the question mark. So for example, I could do question mark and then the memory address 0404, and that returns a value of 23. Each variable takes up 4 bytes. So if I wanted to look at B, for example, I'd have to add on 4 to my memory address. So I'd actually have to go to 0408 and I would see a value of 0. So yes, that's essentially how they work. That's how you can access them. You can set them obviously throughout the course of a program, and indeed you can retrieve them as well, whether you want to use the peek command there or just a straightforward print command with the variable itself. Now, as I was saying before, things can get quite confusing quite quickly with these variables because they don't necessarily have a fixed use throughout the whole program. This is particularly the case with I percentage. This is a very popular variable for using in for loops. You'll see a lot of for loops that go, you can see an example of one here, for I percentage equals 0 to 6, blah, 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 blah. J similarly is also quite a popular one because if you want to do a nested for loop, it's quite common practice to start off with for I percentage equals, and then nested underneath you'll then go into a second for loop for J percentage equals, etc., etc. So I and J are particularly notorious for not having a consistent meaning throughout the program. As compared with obviously variables like this one, space percentage, which its meaning is consistent throughout the program. These resident integer variables, because they are so good at improving the overall speed of the program, they can get recycled and used for a number of different purposes throughout the program, which does make unpicking them a little bit of a challenge. Now there's then yet another complication with using them, which can also make it quite difficult sometimes to understand how the program is operating. And we can see that here. Now I'm not going to go into the details of proc blank in this video, but you'll notice that calling proc blank here is a bit different from some of these other procedures like proc start mystery or proc move mystery here, because it's got a variable in brackets after the call to the procedure. Now, what this is actually making use of is something in BBC Basic that is called call by value, or sometimes known as pass by value in programming in general. Now, there are two ways in which a procedure can make use of variables. You've got call by value, which is what we can see here, or call by reference. Now, call by reference is what a procedure is doing when it doesn't actually have a pass-in variable. So, for example, here, where we've defined proc display invaders, any of the variables that you see sort of underneath, particularly variables where it's not necessarily setting the value. So, for example, missile percentage, this value is not being set by the procedure, it's just expected to already exist and to have already been defined somewhere else. So when the procedure looks at this particular variable, it's expecting it to have a value, and it is the value that that variable actually has independently of the procedure itself. Now this is different because proc blank is actually being provided with a variable, this J percentage variable. Now what that means is that in proc blank itself, the value of J percentage is copied. So if I just jump in briefly, you can see that here J percentage has come in and then it makes use of it, but what it's using at this point is a copy of J percentage. So anything that it does to J percentage is only valid for the duration of the code that is run inside that procedure. So actually, although there's some setting of J percentage apparently taking place here, When this procedure has finished, the global value of J percentage will not have changed. It only changes for the code that's actually run inside this procedure, and that's what call by value means. Now, because I'm not going into the details of what procblank is doing, instead what I'm going to do is use a little bit of sample code here that I've written just beforehand, just to try and explain exactly how this works. So this is a very simple program. It just starts off with clearing the screen, and then here you can see that I have set the A percentage value to 23. That's why it was showing up as 23 earlier. And then what I'm doing is just saying, okay, please print the value of A percentage. So far, nothing particularly exciting. Then I'm making a call to something called proc test, where I'm passing in A percentage. So call by value, I'm actually passing in the variable here. And then a second time, I'm asking to print the value of A percentage. And then that's the end of the program. So what is this proc test actually doing? Well, this proc test takes in A percentage here, and then inside the procedure, it takes the value of A percentage and it changes it. So it says, okay, whatever A percentage might be, which is in this case is 23, I want to multiply that by 4. And then I want to print the value of A percentage. Now you'll notice that other than the fact that I've preceded this with local value of A percentage equals rather than just value of A percentage equals, it's actually exactly the same print statement as we've got up here at the top of the program. So you would think that it would do the same thing, but actually it's not, because here the value of A percentage is local. So the value that's been passed in here is being treated locally. So although it multiplies the value by 4 and then prints it, it won't persist that multiplied by 4 after the procedure has finished. So what we should expect to see is that when the program runs, we would see value of A percentage equals 23, first of all, because that's what we've set it to. Then we jump into this procedure where we pass A percentage in, and it multiplies it by 4 and then says that the local value of A percentage is, and then there should be 23 multiplied by 4, which I think is 92, but we'll find out in a minute. And then again, we have this a third print statement where it asks the program to print the value of A percentage a third time. Although actually, it's not printing it a third time, it's printing it a second time, because this print statement here is not returning us the global resident integer variable of A percentage, it's actually returning a local copy of it. So what we should see in that third print statement on the screen is once again A percentage equals 23. So we shall run the program. And lo and behold, my maths was correct as well. So value of A percentage equals 23. Local value of A percentage, because we multiplied it by 4 inside the procedure, equals 92. But once again, value of A percentage equals 23 because the resident integer variable, the global value of A percentage, has not changed because the procedure simply modified a local copy. Now, if I were to modify this program slightly, you will see that it changes. So what I'm going to do, that was a slightly tautological thing to say. Of course, if I change it, it's going to change. What I mean to say is if I change it in this way to no longer make that pass in variable there. So I'm just going to change proc test to just be that, proc test. I'm not going to pass in a percentage anymore. And indeed, I'll need to change my definition here. So proc test, def proc test without the value of a percentage being passed in. Okay, we'll just list the program again. So now what we should see is 23 being defined at the start. We get a print value of 23. Then we jump into the procedure, but now this is not using call by value. This is using call by reference or pass by reference. So here, line number 80 is now still working on the global resident integer variable of A percentage. Therefore, when it multiplies it by 4 and turns it into 92, we should find that the third print statement continues to show A percentage as 92. So let's see. And there you have it. So it started off as 23. We then went into the procedure and it multiplied it by 4, but it multiplied the actual A percentage resident integer variable by 4, which means that outside of the procedure, its value is still 92 as well. And I can see that if I outside of the program even, I show that A percentage is 92, and indeed if I wanted to do the peeking at the memory address, it's also 92, as you would expect. And finally, just to prove the principle, I'm going to reset my bbem, and I'm going to print A percentage, and it's gone back to 0 because I believe that resetting VBEM is the equivalent of turning it off and turning it on again. So unfortunately, that didn't quite demonstrate what I was hoping. I'm not actually sure how to simulate this because it's quite hard to do a shift brake or a control brake on the VBEM. Let me just see if I can do. Can I do? Yes. Okay. Let's try this. So print a percentage is 0, right? So let's set a percentage equal to 10, let's say. Okay, so print a percentage is now 10. Right, I'm going to do a break, and I'm going to do print a percentage. Hey, there we are. It's still 10. So yes, that kind of did demonstrate the principle that if you were to turn off your BBC Micro and turn it back on again, of course, the values of all the resident integer variables will reset to 0. But if you do a simple break, or indeed a control break, you can expect the values to persist. So that's another nifty feature of the resident integer variables. Anyway, I hope that that's been a helpful illustration of what these letter-based variables are all about. Obviously, when it comes to trying to unpick a pre-written program, as I've been doing with Cosmic Invaders throughout this series, it does require you to spend a bit more time trying to understand, first of all, how these letter-based resident integer variables are being used throughout the program, and secondly, to take note of instances where they might be using call by value, because in those cases, what the procedure does to the variable is actually a copy of the variable, and it won't have an impact for any other procedures that might also be using that variable themselves. So there we are. I think in the next video, as I think I alluded to in an earlier video, we're going to have a look at hacking this program slightly so that rather than just being able to look at variables after the program is finished running, we could actually take a look at the variables while the program is in operation, because that can be a really helpful way to debug the program if it's a program you've written yourself, or indeed to make sense of what the program is doing if, like me, you're just trying to make sense of a type-in listing. So I hope you'll join me for that next video in the series, and until then, goodbye.